Okay, hi, Assalamualaikum. I'm Nuratika. Okay, in this video, I did want to share with you how to do this assignment. Okay, due to the pandemic COVID-19, it's supposed to be a lab session, but due to the pandemic, so our lecture changed it to assignment one. So, okay, in this assignment, the title is a power and a power factor measurement in single phase circuit. Okay, we carry on to the lab sheet. Okay, we know the equipment that we really need is a multi-sim software. So, uh, other than a multi-sim software, we really need a resistor, inductor, and capacitor. Okay, if you see here properly, we really need three type of a different value for resistor and for inductor and also for capacitor. So you really need to focus on this, okay? Okay, go to the synopsis and theory. What is they talking about? Okay, we need to focus on this. The real power dissipated in AC load can be calculated from. Okay, here. What is P? What is Q? And what is S? Okay, a simple explanation. Q. Q is known as a reactive power here. And what is S? S is apparent power. And what is P? P is a real power. Okay, we can see this. This is very simple formula. Okay, for the formula, it's very important for you to remember it because when it comes to a simple formula, of course you need to remember because in final or test or in the lab, you need to calculate and find the value either for P, Q, or S. So this formula is really important. Okay, when we talk about this formula, it will be linked the power of triangle. Okay, a power triangle can be drawn from the value of the real, reactive, and apparent power. Okay, when we found the value for S, Q, and P, the power triangle will be axis. Okay, this apparent power it should be here, Q in here, and P is down here. Okay, we carry on to the procedure. We need to construct a simple circuit for resistor, inductor, and capacitor. So here the lecturers already give the circuit, but this circuit contain everything. It means they have resistor, inductor, and capacitor. Actually, we need to do this one by one because we can see from this table. Okay, this is just for resistor only. Table 1.1. Okay, this for resistor and inductor. And table 1.3 is for resistor and capacitor. So we need to focus on table 1.1. We need to construct a circuit just have a resistor. Okay, in multi-sim we can see this. You can see this. Okay, I already draw this circuit early, so make everything simple and fast and more easier. Okay, so here we can see this is a source of power. Uh, we call it as VS, voltage supply. So in here we have a resistor. Okay, previously in lab they have three different value of resistor, so we need to change it to test and measure it one by one. So firstly they have a 910 ohm, and next resistor is 1.8 kilo ohm, and the third resistor is 3.3 kilo ohm. So we need to measure it one by one. That is how it's been happen. Okay, in here in this circuit we can see, oops, sorry. Okay, we can see here what is this. XWM1 is a wattmeter actually, so we want to measure the power, so we use the wattmeter. And this we want to measure a current, so we set it at ampere. And this We want to measure a voltage, so we set it to voltage. Okay, important thing that you need to know, we need to set it to DC because we use this source. Okay, when everything is had been set, so you need to push this button, run. Okay, and the value will come out. It should be came out right now. Okay, wait. Okay, here. Okay, we can see from this. Yeah, look this. Look, look. Okay. Okay, when the value is top, so this is the value that we need to fill in the table 1.1. Okay, so this is for resistor. Next, for the capacitor, okay, this is inductor. Okay, for inductor, just do the same. The step is same from the previous circuit. Wattmeter and current we set it to ampere, and here voltage. Okay, here. So we just need to run it and wait until the value is came out. Okay, here we go. It already came out and stopped, isn't it? Okay. Okay. Okay, it's already stopped. So this is the value, measurement value that we use in multisim, and we need to fill in at the table 1.2. At the place at the measurement place. Okay. Okay, for this, right now we need to do for capacitor. So like always, like the previous step. Okay, this is a wattmeter, and this is a multimeter. We need to measure our current, so we set it to ampere. Okay, this for measure voltage, so I think okay, it already set it to voltage. And remember, we need to set it into DC. What is DC? DC is direct current. If you set to AC, you won't get that value because we use this source. So this is a DC, direct current, not AC. AC we know as a function gen. We use function gen for AC circuit. Okay, back to this circuit. We can see when you already set this, so we need to push the run button and wait until the value is came out. Okay, we can see that we get a value, and if you can just wait until the value is stop, or if that value can't stop, you just see what is the value that always came out. Okay, it's already stopped. Okay, so this is the value for table 1.3. You need to do this 3 times because okay, like example, this capacitor that the equipment that we need really have is 1 microfarad, 2 microfarad, and 3.9 microfarad. Okay, they contains a 3 capacitor. We need to do that one by one the value for the capacitor. Okay, so we done do the simulation. So when we already fill in this table, so we can just continue to the question and to the discussion and conclusion. So that is just for me for this lab. Thank you.